Hey, my name is Kai, and this is my project on catalysis. I did this project because I'm interested in chemistry, and I didn't know that much about catalysis, and I had discovered a reaction that's really cool that has to do with catalysis, so I decided to do my project on catalysis. So, first of all, what is a catalyst? A catalyst is a reactant in a chemical reaction that starts the chemical reaction but doesn't actually change really during the chemical reaction, or if it does change, it is always the same at the end. So first of all, there are two types of catalysts. The first is a homogeneous catalyst. A homogeneous catalyst is the same phase as its reactants. It's the same phase as its reactants. That means that you cannot separate it from the reactants by mechanical means. So you couldn't filter it, or you couldn't just pick it up out of the reactants. The second type of catalyst is a heterogeneous catalyst, and that is a catalyst that is a different phase than its reactant. So you could just filter it and get the heterogeneous catalyst out of the other reactants. It's a different phase. So my reaction is a reaction between iron in the form of steel wool, hydrogen peroxide in a 6% concentration, and salt acts as a catalyst. This reaction produces iron oxide, Fe2O3, and oxygen, O2. It is catalyzed by the salt because this is just table salt. It increases the conductivity of the hydrogen peroxide, which allows for electron exchange. And that catalyzes the oxidation of the iron, which basically means, it rusts, basically. It turns into Fe2O3, which is iron oxide. And then the iron oxide, as it is generated, the iron oxide, once it's generated, helps to catalyze the decomposition of the hydrogen peroxide and further oxidation of the iron. It produces oxygen gas and iron oxide. It's a very useful reaction if you want to get some oxygen and some iron oxide. This is my reaction. I'm wearing gloves. This is salt, my catalyst. 6% hydrogen peroxide. Steel wool. The balloon I'll be catching oxygen in. My reaction vessel, a candle, and my filtration setup with a coffee filter. And the lighter I'll be lighting the candle with. First I fill the reaction vessel about 3/4 of the way with hydrogen peroxide. Then I add my steel wool to the hydrogen peroxide. I have to break it up to improve the reaction and give it more surface area. I get the balloon ready, and I add my catalyst, which is table salt. Then I add the balloon, and as you can see, by the time I get it on, you can already a little bit of gas is being generated. It stands up straight. I put a rubber band on there so that it'll catch the gas better and it won't pop off. As you can see, now it's standing up straight and it's going to start inflating pretty soon. And it's already starting to bubble. The decomposition of the hydrogen peroxide has begun. Those bubbles are pure oxygen gas coming off. I know this because of the test I will be doing later. There I'm lighting the candle and the balloon is filling up. I'm going to take my balloon of nearly pure oxygen gas and I'm going to put it on the candle. This will make the candle burn a lot brighter. And lights out. It may not be extremely clear in this shot, but look at how much light it produces. You can see it gets so bright. You can see how bright it gets. The actual flame is very small, but it's so bright that it overloads the camera. It is extra bright because because I'm putting nearly 95% oxygen on it, which accelerates the combustion of the candle. This is up from the normal 21% oxygen that is in our air to 95%. As you can see, once the reaction gets going, it's really going. It's overflowing here, and I put on the second balloon. Teamwork. As you can see, the oxygen per generation is much faster, and even when I first put it on, the balloon stands up much quicker. For some reason, the second run was not as impressive as the first one, but it is still possible to see it. I didn't get as much oxygen gas in that run. The reaction is pretty much done, and now I'm filtering it with my little filtration setup to get the iron oxide off. It's pretty warm right now due to the fact that the reaction produces a lot of heat. And both reactions that are happening in there are both exothermic, which means they produce heat. I filter it, and as you can see, the bottom is pretty much clear. In there is just that's basically just salt water left over, which is our catalyst. I smelled it, and it totally smells like salt water. There you can see, I didn't filter all of it, but there's still iron in there. Iron oxide in there. This is the conclusion of my experiment, where I produce oxygen gas and ferric oxide using the catalyst, which is salt, from hydrogen peroxide and steel wool. All of these are common household items. They can be bought in pretty much any hardware store, and this is a great reaction to do if you're interested in chemistry but you don't really have any labware and you want to do something that's actual chemistry. It's not vinegar and baking soda, and it's really cool, and it makes some useful products that you can make other cool things out of. I had a lot of fun doing this. I really like sharing chemistry with other people. Look for my next video, and subscribe.